Alright, vectors. An introduction to vectors is what we're going to look at here. So, vectors in a Cartesian plane. There are a few things that we have to pay attention to. First, you have to pay attention to the magnitude and the direction. Okay, those are two concepts that both make up your vector. Vectors themselves are considered to be like individual segments. However, we can combine them together. We have a very specific symbol that we use for vectors. So for example, we might say that we have vector u. So you would use the lowercase and then you put an arrow on the top, kind of signifying your vector. Or you can use the definition of lines, or of kind of like a array, and you can use the capitals. So like I'm going to look at my vector being between A and B of my line segment, and again you still put the little arrow on top. Now, vectors have an initial point and a terminal end. So the initial point is where you start, and then essentially you would be going through, and the arrow goes at the terminal end. So it's kind of like a start and a stop. Now, when we're finding the magnitude and direction, we have notation that we have to pay attention to. So when we're talking about vectors, we would use double bars. So double bars U, double bars. And what this tells you here is that you are trying to find the magnitude of the vector using the distance formula, and this is the notation that tells you that. Okay. Essentially, to find the direction of a vector, you're using your slope formula. So here you want to think slope formula from algebra. Essentially, remember your m was, say, the change in y over change in x. So you kind of want to keep that in mind when you're thinking about your vectors. So let's go ahead and look at this quick example here to see if this helps. You want to find the magnitude and the vector, or of the given vector, and we're giving you the vectors here, point D and point J, and we want the vector dj. So in other words, what we're saying is we're saying that we have a line here that's going to start at point D, it's going to end at point J. Okay, and what we're looking for is the magnitude of that. So here to find it says that we are looking at finding the magnitude or distance. So we're going to use that distance formula. So again, that formula is essentially x2 minus x1 squared plus y2 minus y1 squared. Okay. So we just need to plug in the information that we have and figure out what our magnitude is going to be. So here we would have 3 minus the negative 1 squared plus 1 minus a negative 1 squared. So here this is going to end up being 16 plus 4, which is going to equal the square root of 20, which reduces down to 2 square roots of 5. Okay, so my magnitude is 2 square roots of 5. Now I have to find my direction. To do that, says I'm going to use my slope formula. So here my m is going to equal 1 minus the negative 1 all over 3 minus a negative 1, which is going to be 2 over 4, which equals 1/2. Okay. So essentially what we have is we have the magnitude of 2 square roots of 5, and our direction is 1/2. Now with this, we can do what's called vector addition. So I just have a couple examples that we're looking at here. Vector addition is the sum of two vectors, and that sum or line is called the resultant. So we've got two ways we can form that. First is to form a triangle. You do that because your first vector starts and stops, and where that first vector stopped, your second vector picks up. And so you can see my first vector is u, so I have u starts and stops, and then v is connected to the terminal end of u and goes up. So this dotted line right here is my resultant, which we would say is adding the two vectors together. Now the other thing that we can do is do what's called form the parallelogram. So what this says is that both of my initial ends, so the purple and the pink are my vectors, they start together but they go off in different ways. So here u is going to come straight off here. My v is going to go straight off this way. So essentially what you do is you would draw your dotted line straight out. You would draw this one straight up, making them parallel to the two vectors you had. And where your resultants come together is going to be your addition. And so here we would then add our two vectors together, this being the solution line. These two things right here being the mirror images of what you actually had here. Okay? So you need to use these two ideas depending on the vectors you've been given in order to try and solve. Now, as an intro, one way that we solve vectors, and a lot of vectors, is by using bearing or nautical type problems. In other words, these are the problems that they use your compass and put a little bit of rotation into them. So let's look at this example. It says a ship first sails north 80 degrees east for 120 nautical miles, and then south 20 degrees west for 200 nautical miles. How far is the ship then from the starting point, and in what direction? Okay. So we need to know how far it is and in what direction. So the first thing we got to do is we actually have to draw this. We need to figure out what exactly is going on. So we're going to go ahead and start by going north 80 degrees east. So if you remember, we have a compass here. Remember, your compass is labeled north, south, west, east. So if I want to go north 80 degrees east, I'm going to start from north and I'm going to go 80 degrees towards my east direction. So that means I'm starting up here in my first quadrant. So I'm going to go ahead and draw myself a decent quadrant here. Alright, so in doing so, I'm going to start here. This is my starting point. And then we're going to go 80 degrees. So that's going to go, let's say it's right about out there. And we're going to go, so this here, here's my north. To go from here to where I sailed was 80 degrees. That means this angle right here is my reference. So my angle of reference is going to be 10 degrees. And then we're going to come up here. This is the first place. Okay. It then says we're going to go south 20 degrees west. So this is where you would want to put in a another example of a compass, because we're going to rotate around one more time. So here we go. Put in your north. And here is my south. So I'm going to go south 20 degrees west. So here is south, here is south, here is west. So I am coming this way. So I'm basically turning around and I'm going to come down, say, to about here. So my ship is going to kind of come straight down this direction. Okay. And we know that this is going to be 200 miles, nautical miles, and this one was 120. Now there's a few things that we know about this. So we know this angle right here from south over is going to be 20 degrees. Okay? But I don't really know anything yet about what else we have. Now, I do know that I then have to connect, because what I'm looking at is how far I sailed. And if you see, I can connect this here to give myself a triangle. So there's a few things that I don't know. First of all, this angle right here we'll call beta. This is what we're looking for. And we can call this distance here x. Okay. So we need to use some current knowledge that we have. So let's go ahead and look. We know that this piece right here is 80, which means this little piece right here has to be 10 degrees. If we look at this line, this one right here, as being a transverse line, and we use, say, our horizontals here as being the two parallels, then this angle has to match this angle right here, which makes that angle 10 degrees. So if I look, I have 20 degrees, I have 10 degrees, that's 30 degrees. This whole quadrant here is 90 degrees. So in order to find this piece right here, this angle right here, which we can call alpha, my alpha is going to be 90 degrees minus the 20 degrees I know, minus the 10 degrees I know, which gives me 60 degrees. Okay, so this right here is going to be 60. Now if you look, I have a side, I have an angle, I have a side. So that right there says that we are going to use law of sines to solve this problem, or at least to get going. We have to be able to find this missing side, and we have to be able to find this angle here. So we have 200 over the sine of my angle is equal to x over the sine of 60. Okay. Well, the angle here is this big, huge, giant one, and my x I don't know. So I need to find my x. So here I can use the idea of law of cosines. So I'm going to use law of cosines to find this x. So that says x squared is equal to my one side, so 120 squared, plus my other side, which is 200 squared, minus 2 times 120 times 200 times the cosine of 60. And this is going to give me this distance here. So what you're going to find out is that x is going to be 174 nautical miles. Once you find out what this distance is, we can now finish using our law of sines. So here this is going to give us 200 over the sine of theta equals 174 over the sine of 60. So here we can cross multiply, so we end up getting 200 sine of 60 equals 174 sine of theta. Divide by 174, so we have 200 sine of 60 over 174 is equal to the sine of theta. So we need to find my sine here. So the first thing we would do, so here you can pull out a graphing calculator, is we would do the top. So I would open a parentheses, and we're going to have 200 times the sine of 60, and we're going to divide that by 174. So here we've got negative 0.3504 equals the sine of theta. So we're going to take the inverse sine of that answer. Always make sure you switch your modes. So let's try this one more time here. A little bit better. So we've got 0.9954. So we're going to try again. The inverse sine of my answer is going to give you that my theta is equal to 84.5 degrees. So I would go ahead in this situation, I would round up to the next degree, which tells you your theta is equal to 85 degrees. Okay? So, what actually was theta? Well, if we look at your theta, theta would be this angle here. Okay? This would be the theta that we just found, which is 85 degrees. Okay? So how does that help us find beta? Well, because the whole angle is 85, and I know that this piece of the angle is 10, that tells you that this piece of the angle has to be 85 minus 10, which equals 75 degrees. Once you know that piece, it's very simple. In order to find your beta, all you have to do is recognize that this here is a quadrant. So what we have is that your beta is equal to 90 minus the 75 you already have, which gives you 15 degrees. And then you need to look at your direction. So here your direction says this is south and this is east. So to find your direction, you would have to state that beta was equal to south 15 degrees east. And with that, it has a magnitude of 174 nautical miles. Alright, so there you have it, your first example of using trig in order to find the vectors of an application problem. So if you have any questions, please let me know. If you have any applications of this nature that are just driving you crazy and you'd like a little bit of help with it, let me know that too. I would be more than happy to work out any additional problems or examples that you need to help you learn. Otherwise, I hope you enjoyed yourself as much as I did, and I look forward to seeing you next time.